Last class we discussed some more problems on finding maximum likelihood estimate. Okay. Today we will discuss about methods of movements. Next method is methods of in this method we equate as many as sample movements as many as sample movements as there are unknown parameters. Solving the simultaneous equations. One obtain the estimates of the movements of the population in terms of sample variance. Just be read those 2 points. I will explain. We know that in general, what is mu r dash? Summation xi power r by n. Then how about expectations? Mu r dash equals to expectation of x to the power of r. What about mu r? Expectation of x minus mu1 dash equals to non-central movements summation xi power r by n. What about central movements? Summation xi minus x bar whole square by n. By n for sample values. Summing and by n. That notation for sample values. Whereas this expectation is for theoretical. If x follows some distribution with some probability, either discrete random variable or continuous random variable. So we take expectations. Now, if any distribution having k parameters, then we find first k movements. Then we solve. That is what these two statements. In this, we equate as many sample movements as there are unknown parameters. So, manaki unknown parameters ennaithe untayo anni sample movements ki equating chestam. Solving the simultaneous equations, one can obtain the estimates of the movements, the population in terms of sample variates. In general, what is mu1 dash? Expectation x. mu1 dash is expectation. Likewise, let x1, x2, and so on, xn, pa, random sample from a population f of x comma theta 1, theta 2, and so on, theta 3. Then the rth sample movement, that is mr, is 1 by n summation x minus x bar whole to the power of r, central moments. This is central moment. That is central. Also, what about non-central moments? M1 dash equals to expectation of x, that is 1 by n summation xi, that is x. In the same way, we continue. Now, to obtain second and higher order weight, ur is mr, but r equals to 2, 3, and so on. The solutions are the estimators obtained by the method of ఒక చిన్న ప్రాబ్లం తీసుకుందాం, so that you will understand it better. Okay, see what theory says. Example. Find the estimate of the parameter lambda of the Poisson distribution by the method of movements. If they ask about movements, I mean method of movement, then this one. If they ask about maximum likelihood estimator, the one which we discussed in the last class. Okay, right, solution. First of all, we need to write this Poisson distribution function. Let x follows Poisson lambda, then probability of function is e power minus lambda power x by x by 4, x equals to 0, 1, 2, and so on. Now, either method of movements or maximum likelihood estimator, we need sample. So, let x1, x2, and xn be a random sample from Poisson distribution P of x from x comma we take mu1 dash. How many parameters are here? Lambda is the only parameter. So first to find mu1 dash, that is mean, population mean. How will you calculate? Summation x into p of x equals to 0 to infinite. Summation x equals to 0 to infinite, x into e to the power of minus lambda power x by x factor. Now this x factorial is splitting into x minus 1 factorial. కాబట్టి first x తీసుకో, మిగిలినంతా x minus 1 factor. Here also you write x minus 1 into lambda. This x gets cancelled. E to the power of minus lambda power x minus 1 by x minus 1 factorial into lambda. When you split this one, x becomes 1 to infinite, not 0 to infinite. Now take this lambda constant, e power minus lambda constant, take it outside, lambda e power minus lambda summation x equals to 1 to infinity, lambda power x minus x lambda power x minus 1 by x minus 1. Now expands. Is that if you expand this, what will it become? Lambda power 0, 1, 0 factor 1, 1 plus x equals to 2. That means lambda by 1 factor. Next, put x equals to 2. Next, put x equals to 3. Lambda square by 2 factorial. Next, put x equals to 4. Lambda power 4 by 4 factorial, and so on. This is our lambda into e power minus lambda into e power. So e power minus lambda into lambda, this becomes, that means mu1 dash is lambda. This is one equation. Now what method of movements is saying that this is population. This is population definition through population. What about sample? Sample movements, that is mu1, m1. M1 is 1 by n summation x. What is this one? X m1 equals to. Now this mu1 dash is replaced with this m1 dash. So this mu1 dash is replaced by this value. That means from these two, say for example this is 1, this is from 1 and 1 lambda equals x bar. Therefore lambda cap is x bar is the method of movement estimator of parameter lambda of distribution. So this is population definition, population mean. If we have a sample, then what is the mean? This one. Now from 1 and 2 you replace this. This is called finding a parameter through method of moments. Finding method of moments. That's next. Write one more question, then you will get it. Right? One more. Write down another example. Let and so on. Xn be a random sample of size is drawn from a population of Bernoulli distribution with parameter P. With parameter Bernoulli distribution, then find method of moments estimated of P. Of moments estimated of first thing. Write down the probability function. Let x follows clearly x follows Bernoulli with parameter, then probability mass function. Probability of x is e power minus 1 minus 0, 0. Now, consider mu1 dash population expectation of x equals to summation x into p of summation x into e power x 1 minus p power 1 minus x 0 comma 1. X is what? 0 comma 1. Now it becomes, now substitute x equals to 0. 0 into p power 0, 1 minus p power 1 minus. Substitute x equals to 0. That's all. Again addition plus substitute x equals to 1. 1 into p into 1 minus p into 1 minus. This becomes 0 because here is 0. This is 1 into p. P. What about this? This becomes 0. So 1 minus p power 0, 1. We will get it. So finally, what is that? mu1 dash is equation number 1. For Bernoulli distribution with parameter p, mean is p. That is population. Now, if we have random set, then its mean m1 dash equals to x bar. M1 dash equals to x bar 1 comma from 1 until 1 3 mu1 dash is P, m1 dash. From these two, replace mu1 dash by m1 dash. That is the case. From 1 and 2 becomes P equals to x bar. That is, or therefore, P cap equals to x bar. Sample mean. What is x bar? Sample mean is method of movements estimate. Method of movements estimate. Movements estimate. Method of movements estimate of parameter. Next, we go for exponential distribution. Next, we go for exponential distribution. Even binomial also. Okay. First, we will solve binomial. Next, go for binomial. Let x1 to x1 be random from a binomial population. Binomial population with parameters then find method of movement estimator of parameter solution. Yes. First of all, write down probability mass function. Let x follows. Binomial is just b. Binomial. Sorry, the size is n. So just replace it. Because we already used this n notation for sample size. So this n and this n are different. So to make that difference, here we are going to consider k. In place of n, we are taking k. Then probability mass function is given by kcx e power x 1 minus 4 k minus x equals to 0 and so on. P lies between 0 and P lies between 0 and 1. Okay. Now, what is mu1 dash? Expectation of x. This is the reason in the first beginning of our estimation theory, I just given an assignment, that is revising of distributions and finding its mean and median. That is the reason I given you that assignment. And most of you done that assignment and you posted in the WhatsApp group. So you just go back. You written in the first page of your notebook for this semester. So just to go back and check it, how you found mean of a binomial distribution. Go and check it and tell me what is that summation x into p of x. Anybody? into kcx p power x 1 minus p power k minus x equals to 0 to k. Instead of k, in your textbook you have it n. Instead of k, you have n. But to deviate from the number of trials to number of independent samples, so instead of n, we are using k here because already x1, x2, and so on xn, we used that n. Okay. This means from the definition of binomial distribution, everyone knows that. Anyway, I am doing once again here. X equals 0 to k, x into NCR equals to n by r into n minus 1 CR minus Here, in place of x, in place of r, we have x, in place of n, we have that. Now, just replace it. A by x into a minus 1 c x minus e power c. When you have x here, you just keep it x equals to and x. So now here it becomes x minus 1. So write in terms of x minus 1. So p power x minus 1 into the p power x. I am going to write p power x minus 1 into p for the sake of convenience. And next one is, see, this is not minus. Do not do minus or minus. 1 minus p whole power, you just write it down k minus 1 minus x plus. Here I subtracted and I added for calculation. When you written in this form, then r is 1 to not 0. So here also x equals to 1 to k. Because when you have kcx, then you can write 0 to k. But whereas when you have k minus 1 to x minus 1, you take x equals to 1 to k. Why we did this math calculations means because we need to cancel this. Otherwise we cannot get it out. Now k is a constant. Oh, sorry. Here one more thing is because here it is p power x. So p power x minus 1 into. Yeah. This k constant here. This p also constant here, take it outside, that is a into p summation x equals to 1 to k a minus 1 c k minus p power k minus 1 minus p k minus x plus 1. Take minus this comma, then x minus 1 x equals to. This is a simply binomial expansion of 1 minus p plus whole power k minus 1 is x plus 5 whole to the power of n is nc0 y power 0 x minus nc0 x power n x plus 5 whole power n is nc0 x power 0 y power n plus nc1 x power 1 y power n minus plus and so on. Ncn x power n y power n minus. That is the same way this expression is nothing but binary. 1 minus p plus p whole power k. 1 minus p plus p becomes 1. 1 power k minus 1. That means what is that? mu1 dash is k. This is mu1. Then what about? This is population mean. Then what about sample mean? Let x1, x2, and so on xn va xn. Right. xn va random sample, then its sample mean m1 dash is summation xi by n, that is x bar. This is equation number 1. This is equation number 2. 3. Do not think every distribution is coming in the same expression, because we have very standard distributions. So that's why we are getting this type of very similar estimation formulas for most of the parameters, because these are all the initial distributions: Bernoulli, binomial, Poisson, exponential, normal. So almost the expression is same. But whereas in the extra class also I told you many distributions are there, hundreds of distributions. For that it's not similar kind of. Here we have a standard distribution. So mostly they are coinciding. Okay? Like from 1 and 2. 1 and 2 replace. Even you can add this sentence to previous problems. From 1 and 2 replace mu1 dash by m1 population values by sample values m1 dash. Then we have, so m1 dash ante emundi x bar. X bar value replaced by, sorry, mu1 dash value replaced by x. That means kp equals x bar. That implies p equals x bar by p equals x bar by. That is p cap equals x bar by k is maximum. Sorry, movement estimator of a parameter B of binomial distribution of okay, that is 3 distributions we have. Next next for exponential distribution, right? So these are the standard distributions only we have. So most of the time we will get maximum likelihood estimator and method of movements estimator seems to be similar, but whereas many other distributions are there, they are different. Okay? Yeah, right. Next question. Next example. Estimate the parameter lambda of the exponential distribution f of x comma lambda is lambda into e power minus lambda x greater than 0. That means 0 to infinity by the method of movement by the first. solution by the methods of moments. Solution. First of all, a given already probability function. So no need to write, or you just say given f of x comma lambda into e power minus lambda x. Right. Mu1 dash expectation of x, that equals to integral x into p of x dx, because since here x is continuous random. If it is continuous, then we should do integration. If it is discrete, then we do summations. Okay. Integration. What about p of x? Lambda into e power minus lambda x. X equals to 0 to infinite are the limits. Okay, lambda is a constant. Lambda is a constant. Take it outside. Write down outside. X equals 0 to infinite. X into e power minus lambda x dx. X into e power minus lambda x dx. Do integration. UV method. So what is integration of UV dx? U is a function of x, v is a function of x. Then what is this integration? U into integration. Then integration. So integration UV dx equals to U into integration v dx minus d by dx of u integration v dx whole dx. This is whole dx. If that is the case, u is what? This is u, this is u. X integration e to the power of minus lambda x dx minus integration d by dx of u. What is u here? X. Integration v dx e power minus lambda x dx. Again whole dx. This is what integration. Lambda into x. Sorry, this lambda is common for entire integration because lambda is x e power minus lambda x by minus lambda e power ax integration dx is what? E power ax by a. So e power minus lambda x by minus lambda minus integration d by dx of x is what? 1. What about this integration? Just now we have it. E power minus lambda x by minus lambda dx. Okay. E power ax by a. Next, lambda into x. What is the limits value? 0 to infinite. And then you will get 0. So e power minus lambda x by minus lambda. Again we need to do integration of this. This minus is minus 1. E to the power of minus lambda x by 1 minus lambda x, we have it, and one more time you will get it because one more time you are doing integration. So into minus lambda. Limits are 0 to lambda. So minus x by lambda power minus lambda x. This also minus plus lambda square. So this is also minus 7 e power minus lambda x by lambda square 0 to infinite. That means upper limit is 0, upper limit is infinite, lower limit is 0. So first we need to substitute infinite. That means limit x tending tends to infinite minus x by lambda power minus lambda x minus limit x tending tends to infinite 1 by lambda square e power minus lambda minus of substitute 0 of limit x tending tends to 0 minus x by lambda e power minus lambda x minus limit x tending tends to 0 e power minus lambda x by lambda square whole bracket. See, integration a to b f of x dx. In case some x ఉందనుకో ఏం చేస్తాం x square by 2 లిమిట్స్ ఏం చేస్తాం a to b ఫస్ట్ b సబ్స్టిట్యూట్ చేయి మైనస్ మళ్ళీ a సబ్స్టిట్యూట్ చేయి. In the same way I just written in the form of limits. First limit infinite minus limit 0 limit to 0 lambda into when n extending tends to infinite this goes to 0 this goes to 0 e to the power of minus infinite. E to the power of minus infinite is what? 0. When x tending tends to 0, this is going to be 0. Then also the total term is going to be 0. This terms only means when limit x tending tends to 0, e power minus lambda. So all are zeros. We already have minus here. Minus of minus limit x tending tends to 0, e power minus lambda into right lambda minus minus plus lambda and lambda square gets e power minus lambda into 0 1. So 1 by lambda. What is this? mu1 dash is what? mu1 dash is what? 1 by lambda. Now sample mean. Sample movement. m1 dash is what? Summation x. That is x. Therefore 1 is from 1 what will you have? 1 by lambda equals to 1 or we need for lambda. So lambda is 1 by x. Therefore lambda cap equals to 1 by x bar. Method of movement estimate. This is what? Exponential distribution. If you have any doubt, you just ask me. Otherwise, we will continue the next class. Thank you.